Europa, one of Jupiter's moons that is not in the Goldilocks zone, remains warm. Jupiter and the moons that circle around it are really sending energy to Europa. Stargazers have been keen on Europa, Jupiter's intriguing moon, for an extremely significant time, from the time it was viewed in 1610 until the Voyager trips in the late 1970s. There were hints that there might be a sea underneath the ice. It required many years of exploration and study for the James Webb Space Telescope to make its astounding 10-hour perspective on Europa. What secret things did this long review show? Might it show that there may be life beyond Earth? What sort of sign is this? Watch as we explore how the Webb Space Telescope examined Europa for 10 hours and then saw what may be an indication of life. Europa is one of more than 90 moons that Jupiter has. It is the sixth moon that is closest to Earth. Io, Ganymede, and Callisto, Jupiter's other three largest moons, were the first moons observed outside Earth's orbit. The Galilean moons were discovered in January 1610 by an Italian scientist named Galileo Galilei, using a telescope he made himself. The surface of Europa is mostly made up of silicate rocks, and it probably has an iron-nickel core inside the water ice. The atmosphere around it is really thin and mostly comprised of oxygen. There are dark, ruddy brown cracks all over Europa's water ice surface. The moon's surface doesn't appear to be more than 40 to 90 million years old, based on the sparse few craters that have been seen. This is exceptionally young in geological terms. Beneath Europa's icy surface lies an expanse of salt water about twice as large as the ocean that covers Earth. Scientists believe Europa might be one of the most promising places in our solar system to search for life other than Earth. Researchers trust that the saltwater beneath its frozen shell holds twice as much water as Earth's oceans and may even contain the necessary chemicals for life. A potential scenario imagined decades ago in science fiction asked, what if life from other planets thrived in an ocean beneath Europa's frozen surface? Europa transitioned from being obscure to becoming a focal point of attention because of this idea, and it has remained so. People, both within and beyond science, are increasingly excited about the prospect of finding life beyond Earth. Using this data, what was once a dream might now be grounded in truth. Spectroscopic studies done with a telescope at Kitt Peak National Observatory in Tucson, Arizona, in 1972, showed that the majority of Europa's surface is made up of water ice. Warm models from 1971 also suggested that Europa might have a layer of liquid water at its center. In the early 1970s, the Pioneer 10 and 11 spacecraft flew by Jupiter, but it was the Voyager 1 and 2 spacecraft that took the first high-definition pictures of Jupiter's moons from a distance of about 1.2 to 2 million kilometers. Voyager 1 came very close to Jupiter on March 5, 1979. The satellite snapped a picture of Europa, and later, on July 9, 1979, Voyager 2 flew by Europa. Extremely close pictures from both Voyager missions showed a surface brighter than the moon's, with numerous bands and ridges across it. There were no large impact craters, high cliffs, or mountains. Europa had an exceptionally smooth surface compared to the other icy moons. The lack of significant impact scars suggested the surface was relatively new, possibly refreshed by ice volcanoes or the icy crust settling under its weight. These discoveries heightened excitement for NASA's Galileo mission, which launched in 1989 and reached orbit around Jupiter in 1995. Galileo's primary objective was to fly by each of the 4 Galilean moons multiple times. Because the data Galileo sent back about Europa was so intriguing, the mission was extended for 2 more years as the Galileo Europa mission. The spacecraft made multiple close passes by the icy moon. One of Galileo's most significant findings revealed that Jupiter's magnetic field had reversed near Europa. This strongly indicated a thick layer of electrically conducting fluid beneath Europa's surface, likely a vast ocean of salty water. Based on data, Europa's icy shell is estimated to be 10 to 15 miles, 15 to 25 kilometers, thick, floating atop an ocean 40 to 100 miles, 60 to 150 kilometers, deep. Despite Europa being only a quarter the size of Earth, its ocean may hold twice as much water as all of Earth's oceans combined. During Galileo's mission in the 1990s, no plumes of water were detected. However, more recent observations from telescopes like the Hubble Space Telescope, along with reanalysis of some Galileo data, suggested Europa might have thin water plumes reaching 100 miles, 160 kilometers, above its surface. In November 2019, a team of international scientists led by NASA announced the detection of water vapor directly above Europa's surface for the first time. A spectrograph at Hawaii's Keck Observatory identified the vapor by analyzing the chemical composition of atmospheres of other planets through the infrared light they emit or absorb. If these plumes are indeed linked to Europa's ocean, future spacecraft could potentially pass through them, collect samples, and analyze them, similar to how NASA's Cassini spacecraft studied the ocean plumes of Enceladus, Saturn's moon. To continue exploration, the James Webb Space Telescope utilized two main instruments, NIRCam and NIRSpec. The near-infrared camera, NIRCam, Webb's primary imaging tool, is a successor to Hubble and Spitzer, designed to capture extremely detailed images in the near-infrared spectrum of light. NIRCam has two sections. One is for wide-field imaging and the other is for coronagraphy, a method for shutting out the brilliant light that stars and planets give off to reveal fainter objects in the background. NIRCam gathers light from the first stars in the universe, as well as stars in nearby galaxies, young stars in the Milky Way, and objects in the Kuiper Belt. Its wavelength range is from 0.6 to 5 microns. Cosmologists can use NIRCam's coronagraphs to take pictures of extremely faint objects that are close to a bright focal light source, like star systems. Coronagraphs on NIRCam work by blocking the glare of a brighter object, allowing focus on a nearby, less bright object. This is similar to raising your hand over your eyes in the sun to better see what's in front of you. Cosmologists intend to use coronagraphs to study the properties of planets that orbit nearby stars. The near-infrared spectrograph NPEC, on the other hand, probes wavelengths between 0.6 and 5 microns. A spectrograph, also known as a spectrometer, is a machine that breaks light from an object into a spectrum. This spectrum reveals information about the object's temperature, mass, and chemical composition, among other properties. The particles and atoms of an object leave unique marks on its spectrum, which can provide valuable insights about its physical state. Spectroscopy and spectrometry are among the best tools for studying the universe because they help decipher the meaning of these spectral lines. The Webb telescope, for instance, studies many extremely faint objects, such as the first galaxies formed after the Big Bang. It takes many hours for Webb's large mirror to collect enough light to produce a spectrum. During its 5-year mission, the NIRC will observe 100 objects simultaneously, enabling the study of thousands of galaxies. The NIRC is the first space-based spectrograph capable of observing more than one object at a time. As for Europa's subsurface ocean and how close it is to the surface, Dr. Gono Vilanua stated, "I believe that question has been a significant motivation for Europa exploration. This suggests we may be able to learn fundamental information about the ocean's composition even before drilling through the ice to get a complete picture." Dr. Gono Vilanua, a planetary scientist at NASA's Goddard Space Flight Center, studies life in space and searches for it on Mars, Venus, ocean worlds like Europa and Enceladus, and primitive bodies such as comets and distant exoplanets. He is the Associate Director for Strategic Science in the Solar System Exploration Division. In addition, Vilanua is the lead scientist for the Comet Interceptor MYUS instrument, a co-investigator for the ExoMars TGO mission, and a James Webb Space Telescope pioneer for the study of Mars and ocean worlds. Astronomers have already used the Hubble Space Telescope to obtain early reports of plumes emanating from Europa's surface. Notably, they used NIRCam to observe Europa while blocking out the light from Jupiter. This observation took place on January 9, 2023, when Europa was approximately 10 hours away from Earth's closest point. Webb's primary mirror, which is 6.5 meters tall, was accurately aligned with Europa during this observation. Both NIRCam and NPEC collected data simultaneously. The researchers reported that Webb did not detect any plumes while observing Europa. However, this does not mean they do not exist. Heidi Hamel remarked, "There is always the possibility that these plumes are variable and only visible at certain times." All we can say with full confidence is that when we made these observations with Webb, we did not detect a plume at Europa. Hamill, an interdisciplinary scientist on the James Webb Telescope project, focuses on planetary systems and the origins of life. She has used various telescopes, including Gemini, Hubble, Keck, and Spitzer, to study the outer planets of our solar system as well as their rings and moons. As a planetary scientist, Hamill has extensive expertise in using Hubble to study the solar system. She led the Hubble team that investigated the impact of Comet Shoemaker-Levy 9 on Jupiter in July 1994, focusing on how Jupiter's atmosphere changed. Here is a closer look at what the James Webb Space Telescope found on Europa's surface. Scientists discovered both crystalline and amorphous carbon dioxide. Amorphous carbon dioxide lacks an organized molecular structure, unlike crystals, which have ordered patterns. Carbon dioxide is one of the most significant compounds on Earth. It is a gas made up of one carbon atom and two oxygen atoms and is believed to be essential to life due to its role in processes like respiration, metabolism, and photosynthesis. Additionally, it is a greenhouse gas that traps heat and impacts the Earth's temperature. First intrigued scientists, leading them to wonder where the carbon dioxide came from. Did it originate beyond Europa, or from specific spots on the Moon? Could it have come from micrometeorites, shooting stars, or other sources? On one side of the Moon, the carbon dioxide appeared concentrated in a single location rather than being evenly distributed. Geologists believe this area represents a new tumultuous landscape. This finding is exceptionally intriguing because it suggests something is occurring beneath the surface. The present question is how the carbon dioxide reached Europa's outer layer and why it is confined to one spot. One possibility is that the carbon dioxide came from Europa's underground ocean, believed to be a potential habitat for life. This ocean is thought to be approximately 100 kilometers deep and contains more water than all of Earth's oceans combined. The water remains in a liquid state due to the tidal forces exerted by Jupiter's gravity. As Europa's interior is stretched and compressed by these tides, heat is generated, keeping the water fluid. Above this ocean, the ice layer is estimated to be 10 to 30 kilometers thick. However, this ice is dynamic, featuring cracks, vents, and eruptions that allow materials to move between the ocean and the surface. The carbon dioxide detected on Europa may have various origins. It could have been dissolved in the ocean water and released as gas or ice due to changes in temperature or pressure. Alternatively, it might have been produced through chemical or biological processes in the ocean, then carried to the surface via currents or jets. The carbon dioxide was found near Europa's equator, covering approximately 12% of the surface in an area called chaos terrain. This region features diverse landscapes such as ridges, cracks, blocks, pits, domes, and depressions. Scientists think the chaotic appearance of the ice results from interactions with the underlying water, causing melting, refreezing, and deformation. This region is one of Europa's most geologically active and diverse areas, making it an excellent target for instruments like the James Webb Space Telescope. Understanding the presence of carbon dioxide on Europa's surface could provide insights into whether its ocean might be habitable. Organic molecules or living organisms might exist in Europa's water, as carbon dioxide is essential for life as we know it. Organic molecules are carbon-containing compounds that are the building blocks of life, including carbohydrates, proteins, nucleic acids, and lipids. When carbon dioxide and water mix, they form carbonic acid, which can break down into bicarbonate and hydrogen ions. These reactions can alter the ocean's acidity, temperature, and chemical composition, potentially supporting various life forms. Carbon dioxide might also be used by microorganisms as a source of carbon and energy through processes like photosynthesis or chemosynthesis. The discovery of carbon dioxide on Europa's surface is crucial for understanding the composition and dynamics of its ocean. It allows scientists to estimate the carbon content in the ocean, how it cycles between different states, and how it interacts with other particles. This information could help design future missions to Europa, such as NASA's Europa Clipper mission. Scheduled to launch in 2024, this mission will conduct multiple flybys of Europa, studying its geology, atmosphere, and potential for life with advanced instruments like cameras, spectrometers, and radar. The Europa Clipper will also deploy a lander to Europa's surface, using data from the James Webb Space Telescope to identify the best research sites. Additionally, the European Space Agency's Jupiter Icy Moons Explore (JUICE) mission, launched in April 2023, aims to study Jupiter and its moons, including Europa. The mission is set to arrive in 2031 and conduct 35 flybys of Europa, Ganymede, and Callisto. These missions mark significant steps in unraveling the mysteries of Europa and its potential for harboring life. They also contribute to our understanding of the broader Jupiter system, offering a fresh perspective on the possibilities of life beyond Earth. Thank you for watching this video. Click on the video on your screen for more content that will captivate and inspire you.